Good morning, everyone, and welcome back to the Identity Management track. This session is about PKI, mostly about PKI, about server certificates, and also about certificates for end users placed on PKI smart cards. Our first speaker is Alex Reid from Australian NREN ARNet, and the speak is about the Australian Identity Federation and how PKI is deployed related to that federation. Alex, please.
Well, good morning, ladies and gentlemen. I work for ARNet as the Director of E-Research Middleware, and also have an appointment at the University of Western Australia, which is in Perth. So I spend most of my time in Perth, but some time each year in Europe, mostly in the UK. This is my agenda for this morning. I want to talk about the Australian Access Federation, but with particular reference to the PKI implementation that we are mounting. So we'll give an overview first, and then talk a little bit about the shibboleth part, and then most about the PKI part. It's only a selection of what I could tell you about the Federation. It's popular today at this conference to quote Sir Isaac Newton, so I thought it would be good to go along with that theme Sir Isaac Newton said, "To explain all nature is too difficult for any one man, or even for any one age. It is much better to do a little with certainty and leave the rest for others that come after you than to explain all things." Now, I'm not sure I can explain even a little with certainty, but I will do my best. Firstly, the context, Australia in the world, as you see. Of course, you will know this is Australia here, and these are the Australian connections through our network connections to the rest of the world. We have POPs in Frankfurt, Singapore, Honolulu, Seattle, Palo Alto, Los Angeles, and Suva, as well as within Australia. So we believe that it's the largest academic network in the world, if only by kilometres. Just to superimpose Australia on Europe to give you an idea of size, that's a map of Europe, and that's Australia to the same scale. So it's roughly the same size as Europe, and the black reds and dots are the network connections and nodes that we have within Australia for AARNet. But I don't want to talk much about AARNet today. It's mostly about the Access Federation, which is part of the higher education and research infrastructure that Australia is implementing. We have this program called Backing Australia's Ability, to which the government has contributed 500 million Australian dollars, that's about 300 million euros, over a period of 5 years, to implement various aspects of the infrastructure to support particularly research, but also higher education generally. And so some of the projects that were funded under the first round was called Systemic Infrastructure Initiative, and the Meta Access Management System, MAMS, you may have heard of, I'll talk a little bit more about that later, was funded by that. We also had a PKI pilot initiated under that program, and then a middleware action plan and strategy which is designed to bring these both together. That has since been replaced by the National Collaborative Research Infrastructure Strategy, which is an overall strategy for developing infrastructure to support research in Australia. And there are 8 discipline areas. Money is being put into particular discipline academic research areas that are considered to be important to Australia. There are 8 of those. And then the 9th area is what we call the platforms for collaboration, which is to provide the underpinning infrastructure for all of those disciplines. So it includes the network, the federation, the Australian Research Collaboration Services. These are services for researchers to collaborate nationally and internationally. The Australian National Data Service, which is only just now starting, and then a National Computational Initiative infrastructure. Looking at the Australian Access Federation, giving you an overview of it, it's important to understand that it's not an initiative of AARNet, of the NREN. There are a number of players that have been brought together to initiate this. Probably the most significant one of these is CAUDIT, which is the Australian University IT Directors Association. And it's in Australia been very active in a number of areas, buying consortia and things of this kind, but it's also recognised the need for developing this infrastructure, in particular the Access Federation. 2 of the major players in that have been AusCert, which is the Australian Computer Emergency Response Team. That's based at the University of Queensland, and Macquarie University, where the MAMS project is located. And then AARNet, in fact, has had a fairly secondary role. In fact, the main role that I've had in advancing the cause of middleware in Australia has been to initiate the MAPS project, which was to try and map out a strategy for how middleware should be developed in Australia to support the whole of higher education and research, and to try and draw together a number of the projects that had been initiated already. As far as funding for the Federation is concerned, as far as development is concerned, the government have made several grants, very large grants, to develop develop the Federation and everything necessary to put into operation. But then the operation itself will not be funded by the government. It will be funded by some kind of subscription service, which is yet to be finalised. So the management and legal frameworks are a little complicated. I will touch on those a little later on. As far as the scope of the Federation is concerned, initially it's higher education and research, and then we're expecting that other education sectors such as secondary education and the vocational and technical education sector will join. But we also expect to interact with other entities, in particular the government, but even now we're already interacting internationally with New Zealand, and New Zealand has been part of this process from the beginning. And maybe others will join later, we'll see. This is the logo of the Federation, Australian Access Federation. And there are a number of other related projects that I won't dwell on now, but just to give you an idea that there's not just the development of the Federation itself, but a number of projects that go to build capability into the Federation. As far as the Shibboleth part is concerned, that's been initiated by MAMS, the Meta Access Management System project run at the University of Macquarie, headed up by James DL, that some of you may have heard of. And it, in fact, has been running a testbed federation based on Shibboleth 1.3 for now a couple of years. One of the problems in Australia is to develop an incentive to join the federation. Unlike the UK, where there's already a body of resources that you need to make available, in Australia we don't have that. Each institution has developed its own arrangements with resource providers. But so we do recognise that there are many resources that could well be shared. And so we've provided incentives both for universities to join as ID providers and also to join as service providers. So they've had some funding to encourage them to release services into the Federation. So as I said, we've had a test operation running now since 2006. It's really in full production, but except there are no legal agreements, no formal policies adopted yet. But it is running and it is used. It's based on Shibboleth 1.3. The WAIF is operated by ARNet in a resilient configuration to give it full production capability. There are about 20 universities out of, there are 39 universities in Australia and 8 in New Zealand. So 20 are already joined as IDP or service providers. There are 23 other entities, various research projects, often associated with the university, participating at level 2. Level 2 is the production level. There are many more that have joined at level 1, but they are that's purely a test mode. We in fact have already 700,000 identities managed by that federation, that part of the federation. Although I have to say many of those are alumni, so they don't really count, I suppose. There are a total of about 1 million students and staff within the Australian higher education and research sector that we eventually will expect to join. And then again, there are additional features that MAMS has been implementing, which are now, some of these are released under the normal Shibboleth release program. Just a quick list of some of the services which are being offered under the Federation. I won't go through those, but it's worth noting, for instance, that we already have a reciprocal borrowing scheme among the 5 universities in Western Australia. So I can front up at a sister university with my University of Western Australia identity card and log in. It checks my credentials back with the home university, and then I have borrowing and other privileges at that university. So that's now all working already. We also have this online librarian between Murdoch University, not to be confused with Rupert Murdoch University, this is a real university, and Macquarie University. There's a 2 to 3 hour time difference between these, and so they use that time difference to extend the hours on which librarians will provide online assistance to students. And the credentials of students are checked using the Shibboleth credentials. We've spent a lot of time developing the schema for the Federation, always, as far as we're possible, derived from use cases that we can positively identify. We've drawn exclusively from existing schemas, except with one exception I'll come to. So we heavily draw on EduPerson, of course, and also SHAC and these other schemas. We have 3 groupings: core, recommended, and other. Core are there's about 5 or 6 attributes which we would normally strongly encourage. We don't make it mandatory, but strongly encourage institutions to be able to provide. And by doing that, we are saying that this will enable you to gain access to almost all of the relevant services. And if you don't provide some of those, then there may be some services that you can't. So it's up to the institution whether they do that or not. Recommended are ones which we do see a need for, but which are not really as important as the others. And other is really everything else in all of these schemas, and we've included it there so that people, if they go looking for an attribute, they think they need to create a new attribute, they really should look at these first. So these are the core attributes. There's nothing terribly remarkable, I suppose, about those, except for this first one, the EduPerson Persistent ID. Because our federation covers not just the student and research population accessing resources, it also includes the grid community and researchers who want to access grid services and the like. We've found a particular need for an attribute which will persist both in time and across service providers. There's been a lot of debate about this. We finally abandoned the name or abandoned the use of this particular attribute, and we're going to call it AU EduPerson Shared Token. So this will be an anonymized token that's generated at the time that the researcher or whoever first comes to the system, and then that will apply to whatever service they go to. So, for instance, in the grid environment, they want to distribute a computational process to 5 high-performance computer systems. Each of those needs to know that it's the same person issuing that program. So that's been quite interesting, and it's only in April of this year that we finally agreed on this AU EduPerson shared token. Moving to the PKI part, which is perhaps the most relevant part for this presentation, I want to talk a bit about the origins, and I'll have another slide about that in a moment, and about the rationale, why it is that we believe it important to have a public key infrastructure installed within the Australian higher education and research sector, and looking at some of the uses. In particular, of course, we already have a certificate service running for the grid community, but what we're implementing will in fact take over from that and make it more robust, and then it will comply with all of the policies and procedures that are already in place for that grid community, complying with the Asia-Pacific PMA and the international ones. We also, of course, need service certificates for various purposes within the community, including, of course, Shibboleth itself. And there has been a goal to provide client certificates, potentially for all staff and students. I'll come to that in a moment. Some of the areas where there's been particular debate have been over the browser recognition root certificate, and we don't want students and staff to be in a position where they have to constantly say yes, this certificate is okay. We want it built into the web browsers, and we have been in negotiations with Microsoft, Apple, and Mozilla, and they have all agreed to incorporate our root certificate into their browsers for all future releases, as long as we go through this web trust audit, which I'll talk a bit more about that in a moment. Because we're going to great lengths to establish this certificate service, we recognise that there may be others interested in taking advantage of this. And in particular, of course, New Zealand will want to take advantage of this. And we've also been approached by Fiji and Hong Kong, and some other nations may well want to take this up. And more about that in a minute. What I've listed here are the original objectives for initiating the PKI project back in 2005. Most of these actually don't apply anymore, but we're now very long way down the path, and so we've, if you like, discovered other reasons for implementing a PKI. But things like sharing resources between universities, e.g. course material, well, of course, that's well and truly provided by the Shibboleth capability that we now have in production already. Needed for graduated degrees of security, that's perhaps something that the Shibboleth environment can't do so well, but it could do that as well, I think. Digitally signing and encrypting documents is something that there still is a need for, perhaps not as great a need as we had thought. For instance, we have one university that's had a certificate service now running for several years, 5 years, and the original intention there was to roll out certificates to all staff and students so that they could sign and encrypt their emails, for example. In fact, they've not done that, and there are a number of reasons for not doing that. They may change their mind in the future, I don't know, but the two main reasons for not doing that, one is the whole problem of managing certificates on behalf of students, revocation lists, all of that sort of thing. It's a very major undertaking for an institution. And the other is the sort of political issues of, okay, so if a student has encrypted their email and they're doing something that they shouldn't do, how can we find out what they actually said in the email? There are all sorts of issues there about privacy and about key escrow and all those sorts of issues that we'd rather not face just at the moment. The claim at that time was that it's the fairly lightweight nature of the trust relationship compared with shibboleth. That's possibly still true. It was also thought that it would be lower cost than a full shibboleth implementation. That, in fact, has proven certainly not to be true. It was expected to provide for authentication, authorization, integrity, confidentiality, and non-repudiation. Well, certainly some of these things it still does apply to. And some of the sample use cases that are used are, for instance, official emails to students, so that if an institution wants to send an email to a student and be sure that they've got it, and the student can be sure that it actually came from the administration, then there's no alternative but to provide some kind of signing of the email. Similarly, if personnel want to send emails to staff to say you're fired or you've got a raise or whatever, it's important that that be both signed and encrypted. And as students, for instance, who may want to submit essays, you may want to be sure as a lecturer that the student it was really that student that submitted it. And indeed, with the signing, of course, you can incorporate the date and time, and so that you know exactly when they did it, and you can resolve all the disputes about, but I sent you the essay, why didn't you get it, and so on. And then, of course, there's the research access to remote resources, the grid computing application, which is still very valid. So, looking at what the progress that we've made to date, the pilot was developed by OSCERT in 2005. That's at the University of Queensland. Policies are still under development. We have obviously built on the policies from both the grid community and other organisations around the world, but we haven't yet formalised them. We are going ahead with this web trust audit so that Microsoft and the others will agree to put our root certificate into their browsers. This is, in fact, proving to be a very costly and time-consuming activity. Firstly, there are the resources necessary to carry out the work. So we've got 2 or 3 staff working full-time, just making the arrangements that are necessary and developing the systems and services and policies and so on. Then, of course, we've had to employ expert assistance from experts within the wider community who are familiar with the kind of security levels necessary for a full PKI, and they've been advising us on how we need to set it up in order to satisfy the needs of the web trust audit. So and then there's the cost of that setup itself, which involves obviously multiple systems in secure environments, so that they're highly secure and highly resilient, even to putting them inside Faraday cages and things of that kind. It's really quite a demanding requirement. Then there's the cost of the initial audit. Originally we had budgeted 200,000 Australian dollars, about 130,000 euros for that process. It's actually going to cost a lot more than that. The only people that can do it are some of the big name consulting or accounting firms, so they charge big bucks for that sort of activity. And then, having done it once, you then have to repeat it every year. It's about half the cost of an initial audit to repeat it. So these are very substantial costs and have taken quite a long time to get going. But we are at the point now where we're nearly ready to initiate the web trust audit or go out to tender for somebody to do it for us. As far as certificate management systems are concerned, we've also been looking at, what what software can we utilize in order to support the central certificate authority and also the institutional the registration authorities in the institutions. We obviously want to keep the price as low as possible, particularly in the latter case, and there have been some interesting developments there, which I'll touch on in a moment. This is our basic model for the PKI with the route up here. We're talking about 4 different levels of certificates from the weakest through to the strongest. We've adopted this particular architecture in order to incorporate old certificate authorities. So I said some universities already have their certificate authorities, and this will enable them to be embraced by the Australian route rather than the route that they use at the moment. And, of course, the grid CA will also be incorporated. And then, of course, it also allows us to bring in a hosted certificate authority for those agencies, institutions that don't want to run their own. We're also then expecting to bridge across to the Higher Education Bridge Certificate Authority in America. This is still work in progress at this stage, so when and whether we'll do that. They, of course, bridge across to the Federal Bridging Certificate Authority. And as it happens, because they also bridge to the Australian Bridging Authority, which is called Gatekeeper, this will enable us, it's actually easier to do that than to bridge directly with Gatekeeper in Australia. So quite a strange, circuitous route, but that's the way governments work, I suppose. In regard to selection of our certificate management system, in the next slide, which I'll skip over very quickly, we have 23 criteria, both mandatory and desirable. We've looked at a range of products. Initially, back in December of last year, we chose the RSA certificate management system for these reasons, that it met the common criteria security evaluation, which is approved at the high level. It's in the DSD evaluation product list, and it met most of the technical requirements. However, on closer examination, it proved that it actually didn't meet all our requirements, and in fact the RSA proved quite difficult about looking at the changes that would be necessary to meet our requirements, and a lot of the things that they had initially said proved not to be true, so we decided that we needed to look further. We certainly looked very closely at OpenCA, but it actually failed on very many fronts. It was really not up to the job of this kind of national enterprise level certificate authority. Finally, in February of this year, we went back to Red Hat, and they have agreed to, that doesn't quite meet all our requirements yet, but they are planning to make it open source next year. And although there are some drawbacks of it, which may impede cross-recognition with the Australian government gatekeeper, nonetheless, both because it will be open source and because they've agreed to make the changes we want, and then we can make any other changes that we want. And being open source, it'll then be free to use for the registration authorities at the various institutions. We believe this is the right choice, so that's what we're going ahead with at this stage. They are the selection criteria. We've looked at these 3 levels of certificate security, starting with level 1, the lowest level, and we've tried, and then go up to level 4. In Australia, we have this system of points for identity. So if you want to open a bank account, you have to have 100 points. This involves having a passport, which gives you 50 points. I think a driver's license gives you 30 points. A credit card gives you 10 points. So you've got to build up 100 points of identity to prove identity before. And if you can do that, then that'll be level 3. It also involves face-to-face appearing in person at the registration authority. So this is a pretty high level, and it's of course not required for most university purposes, but it is required by the grid community. And then level 4, we don't see a particular need for that yet, but it is available. We've looked at length at levels of assurance. How long do I have this now? So I won't go into detail about looking at levels of assurance, but because we require different levels of assurance, we need to be able to communicate that, and so we've looked at the ways in which we do that. using attributes. And there are a lot of issues. The big questions are, should we postpone that until the Federation is launched? We decided we shouldn't do that because the problems of retrofit are so huge, and I think some federations are looking at that and finding it difficult now. We've looked at mapping our levels of security, which is the Audit PKI pilot, level 1 through 4, against some of the, like for instance, the Australian Gatekeeper and also the US Federal Bridging Certificate Authority. And they do map fairly well. And of course, we've kept that in mind. We also looked at how we deploy it and whether we deploy which levels of assurance we employ using Shibboleth and which using PKI. And this is just to illustrate that we're still working through that process, looking at both the strength of authentication mechanism and the strength of the registration of the entity in the first place. So some of the current issues we have in levels of assurance are, what are the business drivers for this? What level of high-value sensitive resources do we want to address in the Federation? What trade-offs should we make between complexity of deployment and potential interoperation with other federations? This question about whether we retrofit levels of assurance, and what are the guidelines and how will they be measured? So it's still a process of active debate and discussion. So looking at the overall progress of our Federation to date, as I mentioned, Shibboleth is in test operation, but which is effectively full production, but no agreement since 2006. We have agreed the schema, and I put a question mark there because there has been ongoing debate. I think that debate is now resolved, but it's only 3 weeks ago that it was resolved, so I'm just wary about other things popping up. But I think that that's now resolved and agreed. As far as the PKI is concerned, we've acquired some of the hardware and software. We've undertaken some of the testing. As I said, we've already had a pilot running, but we need to upgrade that enormously to meet the requirements of the Web Trust Audit. And we're expecting the Web Trust Audit to be undertaken later this year for full production sometime early in 2009. Originally, our plan was to have the Shibboleth part be operational in the first quarter of this year, and the PKI part to be operational in the third quarter. Those have shifted back by at least 1 quarter, if not 2 quarters now, largely because of, in the case of Shibboleth, because we haven't reached agreement on things like the policies and procedures and the operational entities and so on. So the Shibboleth part is in fact an operation, but it's not legally an operation, if you see what I mean. So this governance, management, financial and legal status is still in discussion. But some of these principles are clear. That is, it should be owned by it is and will be owned by the sector. It'll be financed by the sector. It won't be financed by government grants. And we want simple legal arrangements. Again, to quote Sir Isaac Newton, truth is ever to be found in the simplicity and not in the multiplicity and confusion of things. So I hope we try to keep it simple, because then I think we have the greatest chance of success. And these are some URLs for the Federation itself, for a nice video animation, which we've borrowed the ideas very much from the UK video. Our attribute list is here. This is the animation, and this is our what is it? It's the list of people who are in the Federation. So, any questions? Thank you.
Now I'm actually a bit confused by what it is. Let's see. I've at SurfNet, when I was still working there, I have been involved in the SurfNet PKI for many years. And at a certain point in time, we decided, well, all the effort we're putting in our own CA is not really worthwhile. What we should be putting our effort in is actually getting those thingies used. That's when we started the Terrain Service, Certificate Service, and the rest is basically history. What I was wondering about is what made you decide to go for your own CA put all the effort that you need to put in there to do it properly, to put it in, because you said it does take a lot of effort, and I recognize that. I did the calculation some years ago. Came out same amount of money. So why did you go for that instead of just focusing on getting the federated access possibilities out to as much users as you could, and get the certificates, which are basically just tokens, from pay-as-you-go vendors through, I don't know, mass negotiation agreements or something like that?
Well, the basic reason is back in history. And if we were doing it now, we may do it differently. But if you recall, back in 2005, when the PKI pilot was first proposed, the idea was that we'd be issuing certificates to all staff and students, 1 million people in Australia. And our investigations at that stage suggested that that was going to be prohibitively expensive if we were to go out and buy certificates, because they all charge by the user, numbers of users. And so that was going to be ridiculously expensive. And so we decided it was much better if we did our own thing. Now, that situation has changed a bit, because I don't know how many universities are really likely to roll out certificates to all their staff and students. But because we've already put the investment in, most of the investment is already there, it was considered economically sound to continue with this project. And it gives us then the flexibility, firstly, to do that if you ever want to do it. Secondly, to offer it to, perhaps some universities might use it selectively, their personnel department, for instance, for sending out personnel notices, that sort of thing. And there's an opportunity here to sell certificates to the rest of the world. I should say that in our negotiations with Microsoft and Apple and Mozilla, in particular Microsoft has said, we agree to put your root certificate into our browsers, but they've also said, we will never do this again. So any other higher education domain in the world that wants to do that will have to come to us for the certificates. So maybe there's an opportunity there.
Gerti Püss from DFN in Germany. For me this presentation was very interesting, because you have a lot of ideas which we also part of implemented already. We actually have a national PKI running in production for 2 years already. And we have the policy that we are hosting the CAs of the universities in one central point. And then another question comes later, but also in addition to what you said, we also had the problem getting into the browsers, and we choose the opportunity we had our root CA signed by one company who is in the browsers. So we really have the long chain now, which was a bit of a problem because we have a very hierarchical structure in our PKI. So we have the root CA, and every single university has its own CA, but that is hosted centrally in one place in Germany. So that's why this company agreed to sign this root CA. And this is running very, very nicely. And perhaps it was different from the Dutch experience. We have about 200 universities now that are really running their CA, and something 10,000 certificates issued by now in this 1.5 years we are running it now. So it's quite an success. What I was really wanted to ask as well, you said you dismissed OpenCA as not suitable, because we, in this context, we are using OpenCA with some modifications, of course, which have been done, and it's running quite well.
Okay, that's interesting to hear, and very interesting to hear about your success at running CA for 2 years in Germany. And I think some of our people have been in touch with yours to make discussions. As far as OpenCA is concerned, I don't think it's really industrial strength yet, not as required by the Web Trust Audit. That was really one of the criteria. The other was that there appeared to be diminishing support for it among the community that had been supporting it. Now, I don't know if that's your experience, but that certainly was the impression that we had gleaned. Thank you.
Alex, two quick questions. One is Microsoft comfortable with you distributing certificates really broadly around the world? We had heard on an earlier Mace call that they thought they were just servicing Australia, and the second question is the AU Eduperson Share Token. Is that personally identifiable information in the Australian eyes? And do you have a list within Australian eyes of what is PII? Because one of the things we discovered, as you know, on Sunday, is there is no consensus globally over what is personally identifiable information, and we want to function globally.
Sure. On your first point, our information from Microsoft, and we're in constant touch with them in Redmond as well as within Australia, and we've been talking to Steve Ballmer, so it's at that level. They've told us that they are comfortable with us doing this. Now, we have yet to see if the proof is in the pudding. It will be in the eating. So we aren't doing it yet, but when we come to start doing it, then we'll find out. But we've made it clear all along that at least New Zealand will be included, and they've had no qualms about that. But every indication is at this stage that they don't mind us providing certificates to other countries as well. Whether we want to do that is another matter, and whether people want to buy certificates from us is another matter again. But that's in the future, we'll see. On your second point, the shared token ID, it is identifiable. We do have laws in Australia that define sort of privacy and what is personally identifiable and not. But the situation is a little complicated at the moment because we've just been in the process of harmonizing some of those laws with those of America following our free trade agreement with America, which means basically dumbing down a lot of the things that we're doing, I'm afraid to say. There have been some compromises, but I think on that front, we're not worried about the fact that this might be personally identifiable because we will make it clear when people use this identifier that they are sharing, they are making themselves known. It's not machine or humanly readable, so you can't actually get the name from it. But because it's the same token that's going to be used multiple service providers, there is the risk that they could collude. And in fact, we talk about risk. It's not really risk. We actually want them to collude. If you've got multiple parts of a grid environment, we want them to know that it's the same person. So as long as I think we make it clear to people who are using this service that they may be identifiable from this, then we're not worried. Thank you very much.
And then we move on to certificates which are placed on PKI smart cards. And the next speaker is Massimo Valeri from the University of Messina. Please.
Thank you, Michael. Okay, my name is Massimo Valeri. I am from Italy, and today I will present an infrastructure able to manage certificate, able to give some services for a student, employer of university, and so on. Okay, I will give you a brief information about the university, the research at the University of Messina. Then we have an idea of the campus size, the campus in number, and then we can talk about the smart card. For us, the smart card is has a key role inside our infrastructure. Okay, it's important to recognize two different types of services. There are infrastructure services. I don't know if you can see the laser. Okay, infrastructure service and application, because we think the really important things is to do is to give the smart card for the student, but we have necessarily the opportunity to give services to the students. we have two different types of services: network connection and application. Finally, I'll give you a conclusion. Okay, this is a mobile distributed system. This is the group where I belong. And next, the engineering faculty at the University of Messina. I'm a researcher, and right now we are working on mobile, wireless, grid infrastructure. We are already developed the system to get access with the grid with the smart card in G-Lite. Security, performance evaluation, and so on. Then all innovation come from that research group are spread towards a different center, applied research center. The name is CIA, which means Center on Information Technology and Data Application. We want to push toward the common user, student, professor for all campus. Okay. An idea about the university: roughly 40,000 students, 2,000 employers, 1,500 teachers, 11 faculties. It's not too big universities, maybe in the middle in Italy. Okay. Then we talk about the services. We have some services inside in our university, like web-based email, online registration for immatriculation and e-learning, and so on. We want to do a service with a really strong security. We can talk about the mutual authentication. Mutual for us is to provide a certificate for the end user, for the student, inside the smart card. Okay? And same kind of situation with the grid infrastructure. Right now, we have developed the access system with the smart card to improve the security, because we don't want to set the private key inside the user interface of grid infrastructure. Then we have the wireless wired access with 802.1x compliant. So we are moving forward to change every device network access server with this standard. First of all, access point. After that, wired switch. So if you see, there is a bold-faced words like this sentence. We want to do the real-time exam recordation. What mean? We can say inside university, a really easy administrative process is represented by registration of evaluation, exam, and so on. We would like to realize an embedded device with two different smart card reader, with KitPad, with a small display, an LCD, and maybe an embedded device with a very cheap, maybe less 200 euro. Because idea is maybe the reason is always the same. Try to push towards the technology for employers, for professors. They don't have the laptop. The idea to realize a prototype with a simple, really simple device. Okay, and another interesting thing is represented by the possibility to use the smart card like ATM dispatcher. Because what is the idea? The idea is to use the smart card for many situations. So this is the smart card we are delivering to the student. Right now we have about maybe 20,000 of smart cards. This is the first one. The chief of the university, let's say Rettore of the University of Messina. Okay. And the smart card is very simple. It's a pick-up-high smart card with 32 kilobytes of memory and asymmetrically. Right now, the student is generating a key with 2048 bits. Maybe for 10 years, we are enough secure. Okay. Then inside on top of the smart card there is the photo and another personal information, because right now represent the official campus recognition document. You don't need anything else. There is a number of smart card, and if you see, there is a Banco di Sicilia. It's a bank. It's a sponsor. Sorry, I go back again. I forgot to say the sponsor, because the idea is to get money from the bank, because the bank wants to distribute that smart card. The idea to try to do some accounting bank for the student. This is the idea. They give us 20% of cost of smart card. Right now, the smart card has a price maybe €5 for each card. And it's not too expensive, because if you think in Italy, if you would like to try to buy official smart card from CA accredited, you have to spend maybe €100 for each card. It's too expensive for a university and so on. So there is a backside. So I talk about the multifunctionality card. What's it mean? You can use smart card as with the bank agreement credit card. You can use for get money from dispatcher ATM, and for employer, because the employer inside the university has to use the card for the badge. There are 3 different magnetic bands, and the bank provide to fill its organized number and so on. And the last is a badge for refectory services. So the idea is to use smart card for many things. This is the idea. Many benefits with the same cost. Okay? For bank, print service, shop, restaurant, and to give the export the strong digital identity to different type of service. Inside the campus, there are 2 big areas. The first one is in blue is a network access, and the second one in yellow is application. We have developed a lot of applications. This is a picture can show the idea to give many services with the same smart card. Okay, this is Messina. Right now we are talking about the network access. What is interesting, we have the possibility to interconnect with our laptop in every part of the city. There are maybe 8 poles. In the middle there is the headquarter pole. The system is distributed. What is the idea? I think when the professor from Brussels Monday afternoon, we talked about to give some sex about the technology. This is the real reason. When I talk with my student about what do you think with the smart card, I don't like. Okay, sure. What do you think if I can give you a free access around the city? Do you want to buy a smart card reader? Sure. Every student said me, doesn't matter. What's the problem? I can get the access everywhere. I like it. And many students said me, I can get access from my house. Sure. If your house are pretty close to university structure, you can. This is the first reason. Another reason was for employers. Employers, why you have to use smart card, PKI? I don't understand. I don't want. Okay, you can communicate without any problem with the privacy cryptography. It's interesting. So everyone wants some kind of different from real technology. So we pushed from top on different idea, but appear for the student what the sex is, what's the real interesting for them. Okay, 8 poles around 20 kilometers. And 4 wireless access. This is an idea between 2 different points of view. This is the physical placement of each pole. Okay, so each pole represents for us the front office for registration authority array. Okay, in the middle there is a headquarters. If you see, there is a big circle. Okay. And there is the OpenCA, there's the certification authority, it's OpenCA. And right now we have a cloud about the network infrastructure between all poles, and with 2 different types of infrastructure, 802.1x compliant or not. We want to migrate to the final type, so compliant with the standard. Identity, when we talk about identity, is a certificate. X509 or smart card for us is the same things. Okay, but we have we have the cloud about the interconnection. There are two different clouds overlapped because we have inside the city two different backbone of communication. The first one is given by HyperLAN and Owen Bridge, Wi-Fi, and so on. Another one is given by ISP. Maybe it's a fast web, it's an official distribution with for backup if some pole go, the connection is no good. Okay, this is the main pole with some part of the architecture in the right side. In the left side. While in the left side you can see the distributed pole. Okay, around there is the first and the second one. Okay, this is the interconnection. Fast web is a ISP, while there is a backbone with MPLS, HyperLAN, virtual channel. For us is important. While each pole has own LAN to connect the server, user, device, and so on. Okay, if you see, we can mapping logical infrastructure with ISO stack. Okay, there is on the bottom there is the infrastructure represented by metropolitan campus backbone. On top of that, there is a LAN with a network access, like access point switch. And then each access point has to communicate with the radius and so on. If you see, there is only one layer, different between the headquarter and the different poles, is given by green layer, where in the headquarter there is all kind of management system, database, and so on, web portal. Okay, we are trying to use open software, OpenCA. For us, same things we use without a problem. Okay, you need to fix some bugs every time, but it's okay for us because we don't want to spend any money to do this kind of situation. Certification authority, radius server, free radius. Open LDAP, LDAP in master slave configuration. We talk about a bit on that. DHCP Linux-based, binding with LDAP. Of course, network access server, we have to buy access point and switch. We can produce them, and at the end there is the LAMP. LAMP is a Linux, Apache, MySQL, PHP infrastructure to manage everything. Okay, so briefly, this is the idea. The network as a server try to get information from access point. Access point ask to radius verify on LDAP, and so on. And if everything is okay, the user can gain the access. If you see, the user has two different kinds of authentication. We verify strong authentication, what's I mean, with digital certificate, while to give another different type of authentication, we thought about weak authentication for, I don't know, PDA, but I don't like too much this type of authentication. We want to limit the use for maybe PDA, mobile phone, and so on. We want to use strong authentication for server, for device, for laptop, and so on. Okay, monitoring, managing and monitoring means we can use that web portal to make groups, profiles, policy, and so on. We did everything. We have a default profile for each student, so we can fill the database automatically because we have the immatriculation online. So we need to export information from the first database and the second one. The idea to integrate everything, but right now it's not possible. Okay, and there are different user profile, like a professor, employers, the device, server, for different type of connection. This is the web portal. If you see, there is the possibility to verify who does what and where. We don't want to control any user only to want to understand what's happened. With the common name seems to be a strange common name because it's given by a surname / name and specific Italian fiscal code, codice fiscale. Okay, this is an idea. This is a rule becoming from CNIPA. CNIPA is an organization in Italy to try to improve the public administration, and we think it's a very useful thing to use the same rule of the CNIPA. Okay, we can verify everything. We can manage profile like a group. We can put a student for give voice over IP to give to them network access, wireless or wired or both. Everything we can configure everything. Okay, to reduce the fault, we use the headquarter. For us, is the big capability hardware in the headquarter. After that, we try to spread the information, to distribute the information around the pole. Every pole has a copy of LDAP information in master-slave configuration. LDAP has this kind of typology. It's very, very useful. Okay, this is OpenCA, and our first page to use the digital identity with PKI and the certificate. We use the common name with the first, last name, email. We provide all mail for all students. So after the network access, right now we are giving another different type of service like email exchanged in SIGN, encrypted, and so on. There is a simple single sign-on. It's a very simple because it's not really single sign-on. It's like the idea is quite different. We did many software, Java software. If you see, there is the possibility to store each information in our database for each user. What I mean, we are preparing the web portal where you can click without any to put any login and password because you have done the first time, and after that we can store with the smart card every information, maybe in a really secure way. Okay, this is a totem. There is another big problem. We need to spread the applications over all users. Many users in university, like, I don't know, pharmacy faculty or law faculty and so on, they don't have, I don't know, laptop. So for that reason, we did the application, Java application, is without any configuration, any setup. It's really easy to just push your smart card inside the reader and everything is already configured. Like if you see there is a reader, mail reader, so you can exchange mail right now with the administration, with the employer. You can sign the mail, you can encrypt the mail with your friends and so on. If you see there is the LDAP interface to verify automatically, you don't need anything. You put only the name of the destination and everything is really simple. Okay, these are the maybe last slides about what we have developed and what is in progress and what we have in mind. Okay, so we want to migrate all access toward smart card. We want to use strong authentication for many services. And the idea is to produce the embedded device to sign the exams and so on. So, in conclusion, what I'd like to say, for us, smart card represents a simple digital access key. You can get in touch the first time, only one time, okay? So, for us, the certificate inside has a validity for 5 years. Why 1 year? It's too complicated to manage. We don't want that. I talk about that with the leader, CNIPA leader. Doesn't matter. It's only commercial problem. You can use. I have my passport. I can use the passport maybe for 5 years, 10 years. Why the digital certificate has to change every year, to validate every year. Why? It's commercial goals. We are not commercial, no profit. So we can use for 5 years, doesn't matter. You go to the array one time, and then you disappear. Sure. We can empty the queue for receive any document, to receive some things, without a problem. I can send you a mail encrypted for particular data. Doesn't matter. Example, one time we have on our e-learning infrastructure, Moodle-based, there was a professor from Faculty of Law. He sent me, oh, I received a message from nickname, but who guarantee is really who say? Oh, I know, he's a professor. Okay, doesn't matter. With smart card, we know everything. Okay, with smart card you can use for to get the first touch. You go around the world to log in and password, so for email, doesn't matter. You can use, but we don't want to see anybody. Only for the first time, and that's it. Okay, this is my question, because we have some trouble, because we have already done all the architecture. We thought about to belong to education Rome, health Rome, but we have a strong authentication. For us is a downgrade with the login and password. Right now, GAR represents the network infrastructure inside Italy. Is proposing his solution. There is another organization inside Italy, and right now we are a little bit confused with that. Which is the right approach to solution to adopt. We would like to know exactly what we can do and so on. Thank you for attention. If I have exactly 1 minute, I would like to show to you a small movie for to represent. I don't know, Mika, is possible? Olivier, can you? Why this movie? To encourage the student to generate himself the certificate, because maybe this is the really hard part from our work to try. So sorry, this is in Italian, because it's a really I have not the source of that situation. But the idea is this: you have to go to front office to deliver the smart card. After that, you can use the totem. There are many totems around the city, and put the card inside the reader, and open Internet Explorer, Mozilla, and so on. Go to the certification authority, OpenCA, within our front. There is the picture. Push on a request of certificate. After that, you have to put your information, but if you don't understand, you can verify everything. If you see there is a number, right now we have identified number inside the university for each student, and we have the same mail, the official mail, because we want to bind the certificate with the mail. And use right now we have the Gemalto smart card with the 32 kilobyte of memory. It's important, the PIN number. Remember to change the PIN number, because there is the default number 4 times 0. Okay, and PVN, verify number. Go outside the reader, smart card, and okay. This is important in this movie to explain. You have to use the the first time. You have to use the same browser when you do the request, and after when you bind the request with the certificate to put inside your smart card. The same. Medesimo is the same. That's it in our effort. Believe me, it's too hard to try to push toward this technology, but I think can be possible to use PKPI. This is my opinion. I don't know, but okay. Thank you for your attention. I hope everything is okay. Any question?
Very interesting explanation. It's very interesting. Jaap Kuipers from SurfNet, the Netherlands. We have done something with smart cars also, and One of the things I like to know from you is, what is the price of the smart card reader?
€5 for each
The
card.
reader. Do you have? Is it easy plug and play, or every
right now we are
computer?
working on because for the driver, we talk about the driver. Sorry. A little bit tired. You talk about the driver for, okay, well, right now we are working on that because Gemalto don't have any driver for Linux. We did for Linux, and we are producing a wizard to do everything really simple. And our idea is to use the applet Java, so you can do everything without any installation. This is our working now.
The second question is about, you can make payments with this card with the bank?
Sure, in a shop, because there is a band, magnetic band. The bank provide to write some things. You can go around the shop to get a discount and everything. They give us for like a sponsor 20% of smart card. This is the reason, because really cost of smart card is €6, but for university is €5 because we have to get off 20% of come from bank.
I think it's very interesting to learn about this pilot or this project. A question that's always all over Europe is the European banking infrastructure. Can they help us on a larger scale?
I think you can use around Europe because it's like credit cards. It's ATM. I think the bank has the agreement. It's officially credit card without problem, because they write the magnetic field without problem. Sorry, I forgot one thing. In every bank, sure in Italy, I don't know exactly in Europe, but I think it's possible. You can go with your smart card and verify your exams. You verify your everything, information you can print, because there is an agreement. We every day push on a server, a secure FTP, the information. The bank get the information and modify in all circuit around Italy.
Again, very interesting. One question, the last one, is the EMV and the CAP standard. Eurocard, MasterCard, Visa standard is for the European Union the standard to follow. So would be interesting to know in a later stadium if that can be operated with the EMV standards.
Okay, I did an analysis on that. I think the situation right now is possible because we use the magnetic band, okay? It's easy. But in the future, you can't use the magnetic. You have to use two different chips. The same card with two different chips, because it's really far, the EVM from PKA and so on. Maybe it's impossible to use the same type of infrastructure. Okay. Thank you.
And the final speaker in this session is Mr. Urpo Kaila from CSC. And the topic of this speak is the cost and benefit analysis of strong PKI smart card-based authentication. Urpo, please, stage is yours.
Good afternoon, ladies and gentlemen. I'm coming from CSC, which is the organization running the ENREN in Finland, FUNET. We also do have some other services like high-performance computing, grid and supercomputing, IT services, and application services. My current position is IT security manager, so everything which I say is formed by my role a little bit. So I don't want trouble with security. Let's see how this works. This is my outline for my presentation. I would like to rehearse some very basic topics about security. I feel that amazingly, even among very experienced administrators or service directors, some basic terms seem to be forgotten. Then I would like to tell about a project we have been doing in Finland with Finnish universities, with using smart cards and other authentication methods, and then some discussion and thought related to that. Well, this is the traditional CIA model about security, and I want to show it to you. Don't be offended. It is because most of people forget about the availability. Many people think that security is about confidentiality, about locking them out from services and systems, but it is not so. It is really very much about availability as well. Oh, sorry. Therefore, we must always balance those things when we are doing security considerations. Security is not everything for sure. There are some things that are not security, like usability, or what services should we deploy or not, or what should be our availability. It's more to the security role to see that we follow up decisions we have been made, but we should not decide that should we choose Cisco, Juniper, or Windows or Linux, but think about the criteria and make them predictable. So security, in my point of view, is quality. It's not only technical topics, it's very much a management responsibility and responsibility for the organization. And it can be implemented by different type of controls. It should be always based on risks. This is always forgotten. And this is a very standard list of risks we often show. And still today, stealing of accounts is a very, very common risk form. But there are many other risks which are not related to authentication. Infrastructure risk and DDoS and things like that, which cannot be solved with PKI, for example. So some words about compliance. It's not completely our own decision how we define our risk and build up our security controls in our universities. There are laws and many kind of regulation and best practices related to that. And we are expected by our funders and our auditors to follow up those. There's really I think a trend about following different kind of best practices, like the ISO 27001, the ITL, the British infrastructure libraries. But from my point of view, they are very much alike. They have a little bit different angle, but they have all the same message. The amount of detail might differ a bit. But the common thing that at least I feel that the requirements are getting tougher. It's not only more recommendation, but we are being constantly audited and asked that how have you done that? Is it good? And if it's not good, they will come back next year and see what we have done for that. Also here, when it's a network conference, I would like to stress also that there are many types of controls. The technical controls are only one of them, like how we use cryptography or access list or network authentication. But the administrative or logical controls, can be really much more important. And also should think both of these reactive and proactive controls. The best security is done before the incident mostly. And of course we should have some models and practices how to handle our incident, but we must build for security beforehand. Well, here, this slide is a very nice list. It's kind of a security engineering principles I found from the US Standard Institute. It's called Engineering Principle, and they have listed in a very short document 33 good principles, which I find very good, but they are, of course, very abstract. So you need to have the case and adapt them somehow. But this list is about to show that authentication is one of very many other important building blocks for securing your services and systems. Well, authentication, the basic thing is, of course, is the chain here. Let's see. A note here, and you can do it with different kind, but today's world we are really still bound and stuck to the passwords very much, and even to quite bad passwords. We have here in this conference, we had this 6-letter password, and well, I think it worked fine for these purposes, but normally when the password length becomes too long, or when you have so many of them, it really doesn't work. People begin to write them down or having other kinds of shortcut. If you have, for example, installed a file encryption solution on your laptop called TrueCrypt, this open source solution, a very nice one, the default length for your password is 20 characters. And that's already a little bit difficult to remember. And type in all the time. You need to type in it every hour. So it just doesn't scale. But strong authentication means that you need to use several methods. You need to have, for example, something you know and something you have. But this is a very simplified picture of the reality, and I would like to stress out that there really do exist a lot of gray scales here. That it's not a binary division. If you have a well-managed password-based system, it can be much more secure than a badly implemented system with claims to use strong authentication. So, but for the reasons I said, they're really increasing demand, and also the rising user demand, because we are all accustomed to get everything from everywhere right now. And it's very difficult to build fortresses in our networks using these physical controls. And that's why we just need to have some better tools for doing the network authentication. But it's not very clearly said when the strong authentication really is needed, and that's something which we have discussed very much in our project group, and still not perhaps find the very last wisdom here. I looked a little bit what have been studied before here about PKI and strong authentication. There's this famous Schneier and Ellison having make warnings about PKI and thinking that there might be in the future promise, and just through federations and single sign-on, that might be the way to go on. That's written for already 7 years ago. Then I found another paper. It's more kind of a management angle to the PKI problem. But also there could see that it still seems to be difficult, not reliable enough, and quite expensive. There's another project we had in Finland for some years ago called ASTI, where there was really a lot of piloting done in Finland with PKI in universities. And it's very interesting to read it now to see how did the recommendation fall out. And the piloting was quite large scale, and in the project report the writer said that the implementation did work. They could implement it and they were usable, but they were still quite cautious to recommend a very large-scale massive deployment, seeing that perhaps first look at the user management and internal thing, after that get back another time to PKI. And now afterwards it might have been a wise and good and careful decision. But now we have a new time, and we can consider how the technology and the services look right now. So this is a current project I've been involved with as a secretary. It's a joint project for among universities and Finland, and the task was to study how could smart cards and other authentication be used for staff, not student, but staff. But also we should have a look on other phenomena. For example, there's a popular student card in Finnish universities. Could that be combined somehow? Would it make sense? And we had quite a nice organization of the group, because we got a lot of attendance from many universities in a different role, which we also liked very much. That we had IT directors, HR managers, and administrative managers, and then security managers. So there was, we feel, quite a good discussions about the different aspects of the problematic. The objective of the group was to see that could some joint recommendation be agreed on and written. And we had discussed it very, very vividly. We'll have our last meeting now in June. We have written a draft report, and let's see how we will decide on that. Here are some findings we found during the project and during our studies. One is that the roles of a person, it's a very delicate question. We all would like to have less accounts and passwords and cards in our wallets, but it's not very easy to combine those roles. You could add a fourth role, it's the citizen role. And if you lose one of your roles, you cannot lose your other ones. If you're not staff anymore, you can continue as a student or at least as a citizen. That's why it's often quite difficult to combine these identities on a same platform. And also, it was very clearly pointed out of us that these roles are changing very frequently, especially nowadays, that a student can be an assistant during the summer, doing some administration, then again student, and all the access should be revoked during that time. And this must work fast and reliable. Another invention, if you can say so, we made that perhaps we should more think about the services, not the technologies. How to make network access secure, or how make use of some databases secure, not how to use some authentication methods. We think also that we should make some prioritization, that what are really the assets we should protect. They should be protected the most, and which are not that important. Where can we live easily with or without the passwords? Also, we have seen a change since the last pilot, that there really a vast deployment of mobile devices, especially among administrators, and they are doing that for emergency support, using their mobile phone or PDA, and it's very difficult to combine that with a smart card, or impossible currently. And also we find that the currently best technical and economical best solution, it differs over time very much, that you must study it case by case and see how it is in current time. Also, we find that if something should be protected by authentication, that's administrative access to information about people, IDM systems and talk, because that's one of our crown jewels. And I'm afraid that might often be forgotten. Also, root access to critical system is also something that must be protected more than end-user access to system. Fourth, also we would like to report the same findings as the previous pilots have done. Implementation must be tested and piloted very, very carefully, because it's a complicated technology. We have different layers of card. They have changed it here in Finland to the card deliverers. and it must be really tested, not only functionality tested, but tested for performance and access before going to a large-scale deployment. And also, finally, the human side. The logistic is a very critical system. How do you distribute the cards? If you have people who are not present in the city where the university is, you must see that it works smooth enough. Well, this is our draft list about the services to be protected. It is not decided yet, but this is our draft. And we think that the strong authentication should be required in central government services. And that's an easy decision because the government already requires that. But this is still some fuzzy areas here that exactly when and in what areas that will be. There have been discussion that, for example, the Department of Finance, who is running an application for travel expenses for the government official, that they will require smart card-based authentication. Well, then, of course, the number of cards would explode, but you can question that, would that make really sense? Is that the most critical system which you have? That if somebody hack in your travel expenses, it's not end of the world, really. You can make a new bill for that if needed. Also, discussion and more difficult question is where strong authentication should be used is remote administration and remote access. But here we think more studies is needed and what technologies should be used. One considered by many parties is the use of mobile certificates, combining it with phone, because everybody has a phone. But that's also not quite trivial because sometimes the phones are not owned by the university, they are personal phones and they might be tied to the operator. So that must also be studied in more detail. And then you have the other solutions like tokens or secure ID, or which I also think are good solutions. And then finally, strong authentication to be considered, or for example, workstation access or physical access control. These are difficult systems. Workstation access must work because we will have massive control if people can log into their workstation. Also, physical access control is difficult because that's completely a different world. Anybody of you who have operated such systems, they are not open systems at all. They are legacy systems and very rigid, and it's very difficult to integrate them to existing IDM systems. Well, in our project group, there have been some visions. Some of them think that perhaps it should just grow, but there's kind of no clear decisions made about that. There are also been discussion that could a student and staff card be integrated somehow. But there are some difficult points to consider here. How trustworthy are the parties managing the student card, and how can you combine these different roles? So there are some big questions mark there. And also there is a question of bias. Bias to PKI and bias to security. And there's kind of, you can say some feelings and positive or negative attitudes involved as well. We of course try to be as objective as we can. And it's easy to begin with that the very extreme solutions are probably bad. With very bad security or with extremely rigid security. That the truth must be somewhere between. Here's one example of a vision of enlarging card use, but we must see how this happens. This multi-card error means a combination of different card technologies using the chip card and a double chip card with the RFID for the physical access control as well. So there's a vision that the cards could be only technology platforms, and you can tag different kind of authentication methods on that. Here we have done some analysis about the cost. This is a difficult thing because you really need the cost when you have done a bid for tender, made a contract, and looked a couple years ago about what the cost was. But this is the first estimate one of our sub-product groups have made. And you can see that the cost, of course, rises with more functionality. And in our project group, we have discussed card with quality certificates. There's a law in Finland, and I think a European directive also, that you can have an audited distributor of certificates. And in Finland, we currently have only one. And the government requires that for official use, you should use quality certificates. But we feel that it might be a little bit more rigid than the other certificates, and also more expensive. I think I must hurry a bit. I'm a little bit over my time already. Here's the cost-benefit analysis, dividing the cost in operative cost and investment. But the difficult thing is here to estimate what are the benefits. And you would need to study that more, and there's a lot of bias involved, that what monetary value can you give it? It's quite a new thing also in the entrance and universities to really give monetary value for the benefits. But this is an example calculation showing more benefit, and also with some payback time with a reasonable interest rate for only a couple of years. But you can question these numbers. So, to sum this up, we think that we should need to study more on this cost and benefits, what they really are, especially the benefits side, how could we estimate, and also pilot more. But we can see that in other areas like healthcare and consumer finance, we have a lot of cards. I guess you have a certificate-based smart card in all in your wallet here, if you have a modern credit card. Also, the comments we received that, let's sum up here, that deal the challenges here in from the technical side. Also, the role of our universities are changing. They are not tied that closely in the future in the government anymore, so maybe we are not that much bound by government regulation. Also, in the Helsinki University Technology, they have been piloting quite a lot of those, and they showed us a very impressive installation. They have enthusiastic visions about the university with no passwords at all. Very impressive. And they have a combination set up for both Linux and Windows Workstation using the Windows AD that seems to work quite nicely, but it's not in operational use, not in wide-scale real use. That really shows the real risk. So, finally, we think that we need to study the thing more, study it service-based, and also the different authentication methods should be compared side by side and service-based. Then it will be easier to make decisions. The current project didn't have time or resources yet to do that. And also, we think that it might be now a good time to make decisions. The requirements for better and smarter authentication have grown up. And finally, at some point, you need to make a decision. If you continue to use passwords and certificates alongside, people will use the password because that's easier. But the owner of the systems, the universities need to decide about that. So thank you very much for listening to me, and I would like to point out that even if I use the findings of the project group, all the faults and shortcomings here are my own. Thank you.
I'll be quick. There is a U.S. DoD technology that I think everybody should, in this field, should consider seriously and take a long look at, and that's PIV. One of the major problems with in the card business is that vendors are able to lock us into to vendor solutions. So you buy a card from somebody, you get their middleware, and you get everything, right? And you pay a premium for that. Now the U.S. standardization organization NIST has come up with a set of specifications that essentially breaks this all up. And they're forcing, with their big bags of money, they're forcing vendors to deliver what essentially is an open standard for smart cards. And I think that we should take an opportunity, that everybody who's considering buying cards today should take an opportunity to follow that lead, because that will result in a significant reduction in cost. PIV, go Google for it.
Thanks for the comment. That's an interesting view, and indeed there are really a lot of ties here. For example, we had a banking sector who are very eager to also offer services related to IDM, and they do that quite well, but it's really a big political decision that should the universities more large-scale outsource that kind of functions to other companies.
Thank you. This might be sort of a silly question, but how do you revoke the certificates that are in your smart card? What happens when a person loses their smart card that they, what do you do?
Well, the first thing, the immediate thing is that you put it in the CRL, the certificate revocation list, that the services where the smart cards where smart cards are used for authentication, before they accept it, they check the blacklist, the CRL, that is the person there. And that's kind of a built-in in the PKI technology. Okay. But you need to also to take the card away. If the person is not required to have it, then you must physically also take it away. But you can make it functional with the CRL.
Yeah, exactly, because at our university we have student cards with the chip, but when you finish studying, we don't take the card away. You can keep it forever and ever. So.
Yeah, I feel, and I remind that I'm the security guy, so I think that the card should be taken away.
Okay, thank you.
Any more questions? No? Thank you.
Yeah.
And now it's time for lunch, and the identity management track continues in this auditorium with roaming issues.